Previously, when we spoke about matrices, we said that they could be used to solve linear simultaneous equations. And in particular, we could use them to solve practical examples in engineering. Now, before we do that, we need to understand a few more concepts in relation to matrices. And these are the unit matrix, the determinant, and the inverse. So let's first look at the unit matrix. Well, the unit matrix is defined as the matrix with all its major or all its leading diagonals set to 1 and all other elements set to 0. And it's very similar to the number 1 in normal maths. And when we multiply any number by 1, we get the number back again. Well, when we multiply any matrix by the unit matrix, or if we multiply the unit matrix by any matrix, we get the matrix back again. The next thing we want to talk about is the determinant of a matrix. Now, the determinant of a matrix is illustrated or is indicated by the two vertical lines as shown, and we calculate it by taking the difference between the products of the two diagonals. So it's AD minus BC, and this is one single numeric value. So let's have a look at an example. Determine the determinant of the following 2 by 2 matrix. So as we said, it's indicated by the two vertical lines, and the determinant is the difference between the products of the two diagonals AD minus BC. So that's going to be 3 times 4 minus 2 times 7. So it's 12 plus 14, which is 26. So here's a question that you could try yourself. So if you pause the video and see, can you calculate the determinant of the 2 by 2 matrix given? And the answer, by the way, is minus 27. Okay, the next thing we want to talk about is the inverse or the reciprocal of a matrix. Now again, in normal maths, if we multiply any number by its inverse or its reciprocal, for example 8 multiplied by 1 over 8, we just get 1. Well, using matrices, if we multiply any matrix by its inverse, we get the unit matrix. So how do we calculate the inverse? Well, we calculate the inverse by interchanging the A and D and by the way, this is just for a 2 by 2 matrix. So interchange A and D, change the sign of the other diagonal B and C, and multiply the resulting matrix by the reciprocal of the determinant. So that's best seen by means of an example. So here we have one here. Determine the inverse of this matrix. So again, we interchange the diagonal for the 4 and 3, and we change the sign of the diagonal minus 2 and 7, and multiply by the reciprocal of the determinant. So we saw earlier, to get the determinant is going to be 4 times 3 minus 2 times 7. So that's 12 minus 14, which is plus 14, so it's 26. So now that we have the determinant, we calculate the inverse by interchanging 3 and 4, so we get 4 and 3, and changing the sign of the minus 2 and the 7 to become 2 and minus 7, and then multiplying the resultant matrix by the inverse of the determinant, which is 1 over 26. So you could have a go at doing a question now. So here we have one. Determine the inverse of this 2 by 2 matrix. So once again, pause the video and see, can you calculate the inverse of that matrix. And the answer should be 1 over 22 times the matrix 4, 3, plus 2 and minus 5. Okay, so here's another one you can try. Calculate or determine the inverse of this 2 by 2 matrix. And the answer this time is 1 over 13 times the matrix 3 plus 1 minus 5 and 2. Now another important concept is called the transpose of a matrix. And it's to calculate the transpose of any matrix, all you have to do is interchange the rows and the columns. So for example, here we have a 2 by 2 matrix. So if we want to calculate the transpose of this matrix AT, we just interchange the row 2, 5 for its column, so it becomes 2, 5 as a column, and interchange the row minus 2, 6 to become the column minus 2, 6. So let's have a look at an example. Here we're given two 2 by 2 matrices, P and Q, and we're asked to calculate the sum of the transpose PT and QT. So first of all, get the transpose of PT. So again, that just involves interchanging the row and column. So if you interchange the row, 1, 2 for the column, 1, 2, you'll get the following. And minus 3, 5 becomes minus 3, 5. And if we get the transpose of Q, it'll become 3 minus 2, 5, 4. So therefore, to add these two, as we saw earlier, we just add the individual elements. So again, 1 and 3 is going to be 4, minus 3 and 5 is 2, 2 and minus 2 is 0, and 5 and 4 is 9. So here's one that you could try, and here you're given 3 matrices A, B and C, and you're asked to calculate 2 times A minus 2 times B plus C, which we did in a previous module. Then you're asked to calculate the difference between the transpose of A and the transpose of C. You're then asked to get the inverse of the matrix B and then multiply A by C. So there's a bit of revision in this question. So see, can you do that and before we proceed? Now, if you managed to do the previous question, here's another question which is very similar. So see, can you do this question?